All right, so here is the FKM TS18B clamp-on multimeter. This is going to be a great tool around the house if you're doing any kind of small electrical projects, troubleshooting lights, small electronics. We've got a calculator here. We'll actually show you how it works and just talk about some of the things we really like about it, things that we think they could potentially improve, give our overall thoughts. For that, though, I want to thank FKM for sending us this multimeter so that way we can do this demo video for you. Okay, so inside the carrying case here, you're going to get the multimeter that I'm holding, your two probes, and then also this nice wire that you can splice into things as well. And these all are going to go into your two ports down at the bottom. It is a digital multimeter, so you can see there it does have a screen on it, so there's no little dials or gauges. We're going to go ahead and turn it on just so you guys can see right there. Another thing that's really nice about this that I like is that it is automatic for ranging. So like on a traditional multimeter, a lot of times you have to select if you're in the tens, hundreds, or thousands range. This is going to automatically select that for you to give you a precise reading. This is a 6,000 count RMS multimeter, which basically that just means it's going to take a very large average for both sinusoidal and non-sinusoidal electrical sources. So we're going to go ahead and basically just show how it works, try out some of the functions on here, and give you guys a quick demo. So one of the great things about these over the standard multimeters is the clamp. Now, we like having the clamp on a multimeter because you don't have to touch anything. So I've got a fan hooked up here to this extension cord, and I'm going to show you how the clamp works and how it doesn't work. So a lot of people think that if you turn on the fan, we know it's running through the electrical cord right here. All I need to do is switch this to, just lock the fan there. All I need to do is switch my multimeter on to AC current. That's the little wavy line there. AC is what comes out of your wall. I'm going to do AC current or AC voltage. We know that that's a 120 volt outlet, and we're going to find out what the amperage of this fan motor is. So people are going to normally go like this. They're going to turn on their fan, clamp around, and it's not showing anything. That's a problem. Now that's a problem because this is AC, and there's going to be one going up and one going down. So you have two different paths that the current is going to take, and they're going to cancel out. They're going to average out at 0. So what you need to do is, I've actually done that over here on this side, is we have spliced the extension cord. So I have both my positive and negative wire. Now, when I turn it on, I'll only have the positive or the negative, and I'll be able to tell the amperage and the voltage. So let's go ahead and do that. So we're going to turn that fan back on, and we'll demonstrate right here. I've got, we have amps on right now. We're going to get no reading because, again, it's averaging out. Now, if I use one side here, put it in the middle, and you can see there, we are drawing about 0.44 amps, which is just about perfect for a small house fan. Those are normally around half an amp. If I do it on the other side, we're going to get the same reading because the amplitude of that wave is going to be the same whether it's positive or negative. We can do voltage as well. And turn the fan off. We can do voltage as well. And for that, we're going to want to attach our two leads. So we're going to go ahead and turn that off. Attach our input and our common, which is going to be our negative or our ground. Use our two probes here. We're going to pull the little tops off. And then we're going to move over to the outlet. We can now unplug our extension cord. Set it for voltage. Again, this is AC voltage here. And then we have a little screen behind there. So you're going to have to poke past the screen. You're going to do your negative and your positive, and just going to make sure you get right past there. There we go. Get them both in. And if I can make the probes touch, the electrical contacts on the other side, we'll be able to get our voltage. There we go, 123. And as we know, outlets are going to be 120. So we know that that works. All right, we're going to go ahead now and switch to DC. And I'm going to need a battery. So I'm going to go grab one of those real quick. We'll come right back. All right, so we've got that battery here. So now we can do a DC voltage test. So DC is going to be the single line with the dotted lines underneath. That's one way that the current's flowing. So we can put our positive on the positive side or negative on the negative side. And technically, you always want to put your negative on first. We'll go ahead and do that. And I'll let you guys see the results right there. So a AA battery should be about 1.2 to 1.5 volts. And we have there 1.38 volts on a AA battery, exactly what we would expect. So that's our voltage. Now, we've got a whole bunch of other features on here. Let's go ahead and put that guy over here that you can really use to diagnose and test whether or not your electronics are working. So that's going to be under this setting right here, this little multi-symboled one. And you're going to hit the select button, and that'll allow you to switch between things like a continuity check to make sure your wires and your contacts are working. So let's go ahead and do that one. There it is. It's going to be the little loud symbol. Yep, right there. And so we got this little piece of metal right here. So we know that this will conduct electricity. So if I touch this, we should be able to hear the noise. There we go. So that's a continuity check. Same thing if I wanted to check, say, a wire. So we'll check this wire here. So we know this wire is working. We also can test the solder if I go over here. See, that tells us that that solder is actually connected. We can also do things like a diode test. So if I switch this guy to the diode symbol, and we've got two little LEDs here, so we can check that. Oh, wrong way, sorry. And you can see right there. See, I can turn the little diode on. See a little red light? And we're measuring right now at about 1.6 volts. Exactly what we would expect for a little diode like that. Same things, we can check capacitors, we can check the resistors in here. So we'll look for the little ohm symbol, and we can see really just anything what the resistance is going to be on it. And again, you'll notice that the decimal point moves automatically on the screen here as it's trying to figure out what is the resistance, I guess you could say factor. You see how that decimal point moved over? Now obviously it's going to have really low resistance because this is a conductor, but you get the idea. So lots of things that you can do with this. Definitely a step up from your normal everyday household multimeter. You've seen them before, the little red ones with the dial on them. I really do like the clamp feature on these, especially when you're doing things that are a little bit more high voltage or high current applications than what we're doing here, just as an example. So you can see here, right on the clamp, it says you can do a max of 600 amps through here, or 600 volts. So it's going to be quite a bit for pretty much anything in your house. So yeah, great little household tool. Makes it a lot easier to work with wires and things like that. The only thing I'd say that they could potentially improve is maybe a flexible loop adapter. I know you can buy them, but it would be nice to have a flexible loop included with the this one here. That way, if you have to get behind wires or runs like going up against the wall, it's a little easier to get that in and around than the clamps are. But yeah, that's really about it. The FKM clamp multimeter, great tool for the house.